everyone! So let me introduce myself first. My name is Rhea Paculanang. I am 19 years old. I live in Himalalud, Negros Oriental, and I graduated my senior high at Himalalud National High School from the academic track of Science, Technology, Engineering, Mathematics. I am currently studying at Negros Oriental State University Main Campus as a first-year college student taking up Bachelor of Science in Mathematics. And for this video presentation, I will be going to discuss the three topics, which is the integration by yield substitution, the integration by parts, and the trigonometric integrals. And later on, I will show the solutions to my given examples by using these three topics. So let's start with the integration by yield substitution. So when we say the integration by yield substitution, it is also called as the reverse chain rule. It is a method to find an integral, but only when it can be set up in a special way. The first and most vital step is to be able to write our integral in this form. So for example, given the integral of 3x squared multiplied to the quantity of x cubed plus 7 raised to 5 dx. So in this example, we have x cubed plus 7 raised to a certain exponent. Therefore, the value of u is equal to x cubed plus 7, then du, that is the derivative of x cubed plus 7, that is 3x squared dx. So let us half divide both sides by 3x squared, then dx will be du over 3x squared. So let us have the antiderivative of 3x squared, then x cubed plus 7 will be u raised to 5 and dx will be du over 3x squared. And the antiderivative of u raised to 5, that is u raised to 6 over 6 plus c. And this time, we can substitute the value of u, that is x cubed plus 7. So our final answer will be x cubed plus 7 raised to 6 over 6 plus c, or can be written as 1 over 6 times the quantity of x cubed plus 7 raised to 6 plus c. So next topic will be the integration by parts. But first, what is integration by parts? So when we say integration by parts, it is a technique for performing indefinite integration or definite integration by expanding the differential of a product of functions d times uv and expressing the original integral in terms of a known integral v du. A single integration by parts starts with d times uv is equal to u dv plus v du. And then integrate both sides. The integral d times uv is equal to uv, then is equal to the integral u dv plus the integral v du. We know how rearranging gives the formula now. The integral u dv is equal to uv minus the integral v du. So here's the example given the integral of x sine 3x dx. So for a situation like this, know that we have two different types of functions being multiplied by each other, a linear function x and a trigonometric function sine 3x. When you see two different components being multiplied by this, we can use something called integration by parts, and the formula goes like this. The integration of u dv is equal to u times v minus the integral v du. So we need to know the u and dv is. Or we're gonna do is we're gonna make u is equal to x, so that means that du is gonna be the derivative of x, which is 1 times dx or simply dx. Now, dv is going to be sine 3x dx. So if we integrate both sides, the integral of du will get as v, and the integral of sine 3x dx will be negative 1/3 cos 3x. Now that we have this, we can use the right side of this equation. So let's go ahead and plug everything. So the integral of x sine 3x dx is going to be u times v. So we know that v is negative 1/3 cos 3x minus the integral v du, which is negative 1/3 cosine 3x dx. So now, let's simplify the expression. We now have x multiplied by negative 1/3 cos sine 3x, and since we have two negative signs, as you can see there guys, which we can make that a positive sign, then that would become a positive 1/3 and the integral of cosine 3x dx. Then, negative 1/3 x cosine 3x plus 1/3 times 1/3 plus the derivative of cos, that is sine, 3x plus c, which is the constant integration. So our final answer now will be negative 1/3 x cosine 3x plus 1/9 sine 3x plus c. So let's move on now to the trigonometric integrals. So let's talk about the formulas first. When we get the integral of cosine of x with respect to x, that is equal to sine of x plus the arbitrary constant c. And when we get the integral of sine x dx, that would be negative cos x plus c. Just always remember, by getting the integral of secant squared x dx, that would be tangent of x plus c. And if cosecant squared x dx naman, that is equal to cotangent x plus c. And then for the integral of secant x tangent x dx is equal to secant x plus c. And finally, the integral cos secant x cotangent x dx, that would be negative cosecant x plus c. So here's the given example, the integral of 3 sine x plus secant squared x dx. So by using and applying the formulas, sum and rules of integration, the integral of 3 sine x plus secant squared x dx is equal to the integral of 3 sine x dx and then the operation plus the integral secant squared x dx. Then by applying the constant rule of multiplication, this is equal to 3 integral sine x dx plus copy the integral secant squared x dx. Now we can apply our formulas for the integral of trigonometric functions. The integral of sine x dx, that is negative cosine x plus c. So this is equal to 3, and integral of sine x is negative cosine x plus the integral of secant squared x, which is tangent x plus c. Then tangent x plus c, which is the constant integration. Then we just simplify the 3 times the quantity of negative cosine x, which is equal to negative 3 cosine of x, plus we have the tangent of x plus c. Now we have our final answer, negative cosine x plus tangent x plus c. And that would be all. Thank you for watching. Bye!